In a land on Earth, winter can drop below -60 degrees Fahrenheit. Metal cracks at a touch and breath freezes in mid-air. This is Siberia. A region that covers more than half of Russia, where forest ice and marsh merge without boundaries. Many people can swim in ice holes without getting sick. A land where the extremes of the world coexist: the cold, the heat, and life. Lake Baikal, the blue eye of the planet, an inland ocean. In southern Siberia, between snow-covered mountain ranges and endless taiga forest, stretches a vast body of water, deep cold and still to the point the earth seems to be holding its breath. People call it Baikal, the blue eye of the planet. Baikal is the oldest and deepest freshwater lake ever recorded. It holds nearly 20% of the planet's unfrozen freshwater. So clear that light can penetrate hundreds of feet, illuminating even the stones at the bottom. No one knows exactly how long this lake has existed. Sediment samples taken from depths of more than 5,000 feet suggest an age of 25 to 30 million years, making it the oldest surviving lake. In summer, the lake surface is flat, like a mirror, reflecting the Siberian sky. In winter, the entire surface freezes, forming ice more than 5 feet thick, as transparent as glass. Underneath, millions of methane bubbles are trapped stacked into milky white layers, a natural structure found nowhere else. The sun rises, light refracts through the clear ice. Shifting color with every viewing angle from silvery white to blue, while the surrounding space is almost absolutely still. Here, a single footstep lets you hear your own echo. The water here is nearly absolutely pure. Mineral content is very low, plankton is rare. On windless days from the shore, you can clearly see the pebbles at depths of more than 130 feet. Baikal is still expanding. Beneath the lake, tectonic rift zones continue to move silently, pushing out sediment and keeping the lake bed young. That is why, for more than 25 million years, this lake has never silted up. Along the shore, cliffs rise sheer. On Okon Island, white limestone meets dry, golden steppe. Cape Burkan is considered sacred, by local people a rare vantage point. From here, you can see the full sweep of water and the most complete horizon line. The spiritual heart. From the western side of Lake Baikal, at the boundary between deep water and steppe forest, rises an island more than 70 miles long, Okon Island. It is the third largest lake island in the world. And the longtime home of the Buryat people. The western side drops steeply with cliffs cutting straight into deep water. The east slopes gently into dry steppe with layers of sand and fine gravel accumulated by summer winds. Most of the island remains in a natural state almost untouched. Cape Burkan is a place the Buryat consider sacred. This white limestone block, about 40 feet high, juts out into the lake and is one of Baikal's most familiar symbols. Inside is a narrow cave extending more than 30 feet. Where traces of charcoal and animal bones have been found, showing that people lived and held rituals here more than 2,000 years ago. Strong winds from the north blow through the rock, gaps their resonance, creating a bass band below 100 Hz. Instruments from the Irkutsk Institute have recorded this many times, a stable vibration of the terrain. The sound carries for hundreds of yards and is often called by locals the breath of stone. On top of Cape Burkan, 13 wooden surge poles stand in a row. Each pole is 7 to 10 feet high, made from pine or birch trunks wrapped with colored cloth called kadag. The 5 main colors symbolize natural elements: blue for the sky, white for wind, yellow for light, red for fire, and green for earth. In shamanic tradition, wherever there is a surge, the place is considered a sacred space, a boundary between humans and the spirit of the landscape. On windless days, the water around Burkan reflects the entire row of poles. And the light from the white rock. When the temperature falls, moisture from the lake slowly crystallizes on the wood and cloth, signaling the moment the lake's surface is about to freeze. 3. When winter turns water to crystal Baikal's winter begins when the air reaches minus 30 degrees Fahrenheit and stays there for many days. In just 2 weeks, the largest freshwater lake in the world turns solid. The ice is so clear you can see through nearly 40 feet of water down to the gas streams trapped below. When pressure rises, the ice cracks, expelling cold air with a sound like a gunshot. This happens suddenly, often at night, in complete stillness. In sunlight, the ice shifts color, continuously blue-silver, then gunmetal gray. Optical measurements show the highest albedo around mid-January, when air humidity is at its lowest. Each step on the ice creates a hollow sound that spreads in circular waves. The speed of sound in Baikal ice is nearly 12,000 feet per second, more than 10 times faster than in air. By midwinter, dark ice rings appear on the lake surface circles miles across that cannot be seen from the ground. Scientists think these are traces of warm water currents moving beneath the ice, but the exact mechanism remains unexplained. When the wind stops, the lake emits a series of low-frequency echoes that people call the Song of the Ice. Acoustic waves created by uneven expansion of the ice, a natural but almost unreal sound. Along the shores of Olkhun, seepage from the cliffs freezes into clear ice stalactites. Light passing through creates bands of blue and green, the result of high dissolved oxygen. The lowest temperatures can reach minus 60 degrees Fahrenheit. At that point, the ice becomes stable enough to bear the weight of motor vehicles. People use the ice surface as a temporary road connecting the island to the mainland. But the ice is never completely still. Under that transparent layer, water is still moving slow, silent, and invisible to the naked eye. In that quiet space, life persists. Tiny clusters of algae keep photosynthesizing beneath the clear ice, forming the first energy chain of winter. 4. A unique ecosystem. The deeper you go, the more stable Baikal's water temperature becomes. Under the thick ice, the water rarely falls below 36 degrees Fahrenheit. At that temperature, algae, microorganisms, and deep water fish remain active. Among Baikal's species, the Golomyanka fish account for the largest biomass. Their bodies are transparent and contain more than 30% oil, helping them withstand high pressure and low temperatures. Golomyanka give birth to live young instead of laying eggs, a rare trait among fish. Each can carry thousands of fry and release them directly into the mid-water. Thanks to the abundant energy from body oil, they become a crucial link in the lake's food chain. The Baikal seal, the Nerpa, depends almost entirely on this fish. They dive to more than 400 feet to hunt using thick blubber and exceptional oxygen storage. When they need to breathe, they find natural openings in the ice or use their foreclaws to clear snow and open air holes. In the dim light, filtering through the ice, the seal's shadows glide slowly, stirring the water hardly at all. Each individual can range more than 50 miles during winter. Some move near Olkhon's shore. Others head south along warmer currents near the Selenga River inflow. When the ice breaks up, seals haul out on exposed rocks or empty sandy shores. They give birth on remaining ice, where dry wind and long sight lines help avoid predators. Pups weigh less than 10 pounds, covered in thick white fur that lasts only a few weeks before they molt to darker coats and begin learning to dive. Scientists still have not determined exactly when seals appeared in the lake. Genetic traces show they split from ancestors in the Arctic Ocean hundreds of thousands of years ago. Every species here, from algae and fish to mammals, has evolved under its own rules, with perfect adaptations to an environment that has changed little for millions of years. At the end of winter, the light weakens, the surface begins to show long black streaks, miles in length. This is a sign of heat building inside the lake, heralding the melt cycle. From afar, in absolute stillness, you sometimes hear a faint metallic echo. It is the sound of a train passing along the southern shore, running on the Trans-Siberian Railway, the only road linking this frozen region to the rest of the continent. A steel ribbon binding a continent one. The Empire's dream. At the end of the 19th century, the Russian Empire held territory from Europe to the Pacific, yet most of Siberia remained an inaccessible void. From Moscow to Vladivostok, the 3,000-mile journey took more than 3 months. In 1891, Tsar Alexander III ordered the construction of the Trans-Siberian Railway, a project to connect the entire territory with a single steel line. Work began simultaneously at both ends, Vladivostok in the east and Chelyabinsk in the west. What few people know is that this line was designed and built mostly by manpower with rudimentary tools in cold so severe that hammers snapped on steel. Thousands of prisoners and peasants were conscripted. The biggest problem was not distance, but permafrost, thick layers of ice feet below the surface. If it thawed, the entire line would sink. To counter it, they designed a ventilated roadbed that allowed cold air to circulate and keep the ice stable. When the Russo-Japanese War broke out in 1904, the line, though incomplete, was immediately put into use to move troops to the Far Eastern Front. In 1916, after 25 years of construction, the line was officially completed. The first train to run the full route took more than 2 weeks. A century later, trains still travel the same steel, passing birch forests, steel bridges, and permafrost. Two, a journey through the heart of Siberia. The Trans-Siberian stretches more than 5,700 miles across 7 time zones and more than 4,000 bridges. It is the longest continuous railway in the world, operating steadily for more than 100 years. Each year, more than 80 million tons of cargo move along the rails, mostly oil, coal, and metal ore. Yet the noteworthy part lies beneath the track. Nearly 1/3 of the line lies on permafrost, where ground temperatures never exceed 32 degrees F. If the ice thaws, the roadbed can collapse in hours, so the ventilation system is maintained to stabilize heat. The section that clings to cliffs along Lake Baikal required 39 tunnels and more than 200 bridges cut through solid rock. Inaugurated in 1905, engineers called it the road hung over the water. More than a century later, the original steel and stonework still stand. The train passes through more than 1,000 miles of taiga, the largest forest on Earth. In winter, temperatures can drop below -40 degrees Fahrenheit, and radio signals fail for hours. Steel rails shrink about an inch each night, and workers still check each section by hand. Leaving Moscow, the train shares latitude with Copenhagen. Reaching Vladivostok, it shares longitude with Tokyo. A full journey takes more than a week to complete, linking 2 oceans, 2 continents, and 2 worlds. The train leaves the frozen forest, and the first lights of Novosibirsk appear on the horizon. Part 3. Novosibirsk, the brain of Siberia 1, a city born of the railway. Novosibirsk sits on the south bank of the Ob River, nearly 2,000 miles east of Moscow. The city took shape at the end of the 19th century, at the point where the Trans-Siberian Railway bridged the region's great river. Straight, wide boulevards cut across one another in geometric planning surrounded by Soviet-style blocks. Large in mass, sparse in detail, optimized for cold climate. At the city center are the main square and park, laid out symmetrically along the railway axis. The building's dome spans more than 200 feet larger than the Bolshoi Theater in Moscow. Inside the hall seats more than 1,700 the stage runs, nearly 100 feet deep. And the entire mechanical system has been electrically operated since the mid-20th century. The monolithic dome is more than 2 feet thick, with no supporting columns, one of the largest domed structures in Europe at the time. In winter, the entire square in front is covered in snow. Light reflecting off the dome creates a continuous band of brightness. At -40 degrees Fahrenheit, the ice layer on the roof maintains optical clarity thanks to steel's low heat absorption. The theater operates year-round with touring companies from across Russia. From above, Novosibirsk appears as a clear geometric network blocks arranged along transport axes and squares, split by the Ob River and the Transcontinental Railway. 2. Akademgorodok, a Silicon Valley in the taiga. Akademgorodok lies about 20 miles south of central Novosibirsk. This area was chosen as a science center in the late 1950s amid taiga forest and the artificial Ob Reservoir. Winter temperatures can stay below -40 degrees Fahrenheit for weeks. The climate seems better suited to polar bears than to scientists, yet that harshness and isolation were precisely why the site was chosen, separated, stable, and hard to reach. Of Akademgorodok is forest. Research institutes, dormitories, and housing are set among pines and snow, connected by narrow, ice-covered walkways. At the heart of the complex is Lavrentiev Prospect, a 1.5-mile-long street recorded in the Guinness World Records as the roadway with the highest density of scientific institutions in the world. More than 20 research institutes line this avenue, from physics to applied biology. Buildings are low, with broad glazing arranged parallel to the wind to reduce snow accumulation. At night, white light from laboratories reflects off snow and forest, forming a dim ribbon along the edge of the Ob Reservoir. The lights fade in deeper ice country. Another city glows differently, the metallic orange of smelters' smoke and industrial vapor. Part 4. Norilsk, an industrial city in permafrost. North of Novosibirsk, the taiga gives way to frozen plateaus. At 69 degrees north, Norilsk appears as a self-contained industrial cluster in permafrost. The city began as forced labor camps in the 1930s. The first blocks were built by Gulag prisoners with raw materials and simple mechanical tools. Most residents today are their descendants, generations born and raised amid extreme cold and industrial smoke. Norilsk is considered the most polluted city in Russia. Today, it is the largest metallurgical center in the Arctic. More than 20% of the world's nickel and much of its palladium are extracted from mines around the city. The entire process from mining to smelting to transport is run by Norilsk Nickel. The air carries sulfur levels tens of times higher than safety standards. Smoke from hundreds of stacks lays a thin gray haze over residential districts. Trees in the surrounding region die off for tens of miles, leaving a bare landscape interspersed with white snow. The Daldikan River to the south often turns red from nickel oxides in the water. In 2016, satellite images showed the river deep crimson after a spill from a smelter. The stain still clings to the riverbed, visible each time the winter snow and ice melt. Norilsk residents live in isolation. There is no road connection to the rest of Russia. In summer, goods arrive via the Yenisei River. In winter, only air remains. Vehicles must idle constantly, and heating pipelines are set above ground to avoid freezing. Beneath the ice, thousands of meters of ore continue to be mined, the only energy source that keeps this place alive. When thaw season comes, smoke thins. And to the east on the horizon, a dim light begins to appear. It is the sign of Kamchatka, a land where heat comes not from smelters, but from the hearts of active volcanoes. Part 5. The Kamchatka Peninsula, a land of fire and ice. 1. The Pacific Ring of Fire. At Russia's far east, Kamchatka stretches between the cold Okhotsk Sea and the Pacific Ocean. The area has more than 300 volcanoes, 29 of which are active. Volcano density here is the highest in the Northern Hemisphere. Seismic sensors register, on average, more than 1,000 tremors annually, most near volcanic vents. Kluchevskaya Sopka is the highest peak, more than 15,000 feet. Its elevation continues to rise as volcanic material accumulates after each eruption cycle. Ash can reach the stratosphere and spread hundreds of miles. Some areas around the base remain covered with ash layers more than 3 feet thick, creating new strata every century. Some vents exceed 1/600 degree. When lava cools, it forms dense rock with crystals of sulfur and silica. Over time, layers of rock stack up, marking each eruption. The landform changes by the year. Some new peaks appear, and some old craters are completely buried. The Karimsky-Bazimiany and Tolbachik cluster is the most active zone. Every year, thousands of small tremors are recorded around them, signaling the movement of hot material underground. Lava flows miles long remain warm for months, leaving a dark red signature in infrared imagery. From above, Kamchatka is a continuous chain of volcanoes, glaciers, and ash plains. Smoke, steam, and melting snow interlace to form slow-moving bright patches. The only sound is steam bursting in the cold air. The breath of the earth. The Valley of Geysers lies in central Kamchatka, nearly 4 miles long. More than 400 geysers, mudpots, and fumaroles operate within less than 20 miles. Average temperatures of the vents exceed 200 degrees Fahrenheit. Some water columns shoot more than 200 feet high, and steam blankets the whole valley. The constant sound of boiling water and compressed vapor forms a natural drone. Audible from miles away. The ground is coated with gray-white sinter from sulfur and silica, deposited over thousands of years. In the most active zones, surface temperatures exceed 250 degrees Fahrenheit. The steam is so dense that visibility drops to just a few dozen feet. After a landslide in 2007, part of the valley was buried, but many new vents appeared to the east. From above, the area appears as a network of fissures and hot streams venting without pause among snow-covered slopes. The mist lifts, and in the distance stands the Karimsky volcanic range, where ash and lava still glow in the dark. 3. Kingdom of brown bears and salmon. When the snow is gone, water from the slopes drains into the warmer rivers around Kamchatka. It is the time for salmon to begin their upstream run. Dense schools move steadily, forming bands of motion under the shallow water. Upon reaching the shallows, fish begin to spawn. They dig into the gravel with their tails, forming small pits, then cover them as soon as the eggs are fertilized. Most will not survive this stage, and carcasses line the banks to feed other species. Brown bears arrive in step with this rhythm. They step into the cold water and stand still. The fish brush against their legs, and a light swipe of a foreclaw is enough to toss one from the water. A bear's reflexes are near perfect. They do not chase. They only wait for the exact instant. Each bear eats dozens of fish a day, mostly fat-rich females. Cubs watch from the bank, copying their mother's movements and learning to read swimming direction and water depth. The salmon keep pushing upstream, clearing rock steps and small falls until they are spent. The hunt ends, temperatures drop, and fog thickens. Grass turns grey, the first snow appears on the far ridge, deeper into Siberia. Part 6. Yakutsk and Oymyakon, the heart of permanent winter. 1. Yakutsk, a city on permafrost. Cold air from the polar regions flows south and covers the Lena River Valley. Yakutsk enters a long season of bitter cold, the sky holding a dull grey for weeks. The ground beneath the city is permanently frozen. Buildings are set on concrete piles separated from the soil. Water and heating systems are not buried but raised above ground, wrapped in multiple layers of insulation that weave around residential areas. Each pipe segment has a relief valve in case water freezes inside. In the deep cold season, the sky has no blue. On the streets, everything moves slowly. People do not turn off car engines even for a few minutes. On window glass, frost forms several inches thick overnight. They scrape it each morning. But vapor fogs the pane again within hours. The world is seen through a white haze. Indoor temperatures are kept stable by a central heating system that runs continuously. Devices, wiring, and vehicles are designed specifically for the Arctic, with cold-resistant materials and backup power kept in jacket pockets to prevent freezing. At the coldest point of the season, the sun rises only a few degrees above the horizon. At noon, the light is still weak and almost shadowless. Breath freezes in the air. More than 300,000 people still live here. In an environment where most materials are brittle and easy to shatter. Streetlights glow day and night, and heating smoke forms a veil around the neighborhoods. Farther out, the Lena River freezes solid. Its surface so flat it becomes a winter roadway. On that ice, faint tire tracks fade into the mist toward deeper cold, where Oymyakon begins. To Oymyakon, the cold pole of the Northern Hemisphere. Temperatures in Yakutsk are already beyond ordinary endurance. But to the southeast lies a place colder still. Oymyakon sits among high ranges in a narrow valley where cold, heavy air is trapped. Wind cannot escape. And temperatures fall hour by hour until they stabilize at their lowest. The coldest temperature ever recorded here is minus 96 degrees Fahrenheit, an extreme rivaled only by Antarctica. In winter, the sun appears for only a few hours, the light weak and insufficient to melt the frost. The air is so dry that moisture crystallizes the instant it touches skin. Oymyakon's residents live scattered along the main road, mostly indigenous families settled for generations. Houses are heated with coal and wood. Water for daily use is cut from river ice and melted day by day. Food is stored outdoors year-round in natural cold. The sky hardly changes color throughout winter. The sun briefly shows, then disappears behind the mountains. The landscape is completely white, with no boundary between land and air. On the coldest nights, ice fog crystallizes aloft, forming vertical light pillars along the horizon. This happens when ice crystals reflect the village lights, the only illumination during months-long nights. Beyond the ridge, lies the Mere mining region, where people drill into permafrost to seek minerals formed in rock millions of years ago. 3. Diamonds, beneath the ice, amid permafrost. Yakutia sits on one of Siberia's largest mineral belts. The city of Mirny is its center. At a glance, the town seems ordinary Soviet-style apartment blocks, warehouses, and steady truck traffic. Then a circular pit opens more than a mile across and nearly 3,000 feet deep. This is the Mir Diamond Mine, one of the largest open-pit excavations ever made by humans. The mine was discovered in 1955 when geologists found signs of a kimberlite pipe, an ancient structure where magma once pushed diamond-bearing rock toward the surface. Extraction began soon after. In temperatures down to -60 degrees Fahrenheit, machines were redesigned to withstand this environment. Fuel, preheated hydraulic oils, switched to special grades, tires reinforced against cold cracking. The pit widened year by year, forming a spiral that burrowed into the earth. When wind crosses the rim, pressure differences create a strong suction effect, and all civil flights avoid this area. After open pit operations ended, vertical shafts were sunk to deeper levels. Activity is monitored by radar and thermal sensors to control permafrost stability. Beneath permanent ice, people keep digging. Layers of rock ash and diamonds are removed, leaving a vast hole, a trace of human presence in an extreme environment. Part 7. Pleistocene Park, an Ice Age experiment. More than 200 miles beyond the Arctic Circle in the remote Kolyma region, a reserve called Pleistocene Park is being established. The project was initiated by biologist Sergei Zimov in the late 20th century, aiming to restore the ecosystem of the last ice age when cold steppe dominated northern Asia. He argues that the disappearance of megafauna bison, horses, reindeer, mammoths is the reason the surface softened, retained heat, and accelerated permafrost thaw. Yakut horses, the only breed able to withstand temperatures below -50 degrees Fahrenheit, were released first. They survive by digging through snow to find dry grass and create bare patches where thin snow lets cold air penetrate deeper. Then came bison, brought from Canada and Alaska. Their coats are nearly a foot thick, and they weigh more than 2,000 pounds. Bison compact snow with their hooves hardening the surface and preventing summer heat from penetrating the ground. And finally, reindeer completing the food web and regulating vegetation. They move in herds, leaving clear tracks through the snow. In winter, the animals share the same food source layers of dry grass stored under snow. The ground surface holds deeper cold, and thaw slows. When wind sweeps the plains, herds of Yakut horses move in lines. Bison break snow to find grasses, and reindeer stand in small clusters on the slopes. There are no fences or barns. The entire area is left to self-adjust. Every movement contributes to the thermal balance of the ice below. This is one of the rare places where people do not open mines or build factories, but attempt to restore what disappeared thousands of years ago. On the map, Siberia is a white expanse that spends half the year under snow. Beneath that ice, the ground still shifts. Rivers still flow, and fire still smolders in the hearts of mountains. Even in cold so bitter that metal shatters to the touch, people continue to live within it, to build, to mine, and to record. Siberia's story continues along with winters that have never ceased.